Assalamualaikum warahmatullahi ta'ala wabarakatuh to my fellow panels, Associate Professor Dr. RAMZYZAN bin Ramli and Madam FARRAHSHAIDA binti Muhammad Saleh. I am Luqman Hazeeq bin Ahmad Izuddin, the final year project 1 student, will present my proposal with the title of Design and Simulate an Automatic Bottling Packaging Machine. I am under the supervision of Dr. SUKARNUR ABDULLAH.
I will begin my proposal presentation on project summary. In this study, the automatic bottling packaging machine for 24 of 500 ml bottle into box is designed and simulated. Computer-aided design, or known as CAD software such as CATIA, is used in design and simulation process for prototype of the machine. Cost and material to fabricate the machine are considered in the design process. The machine will use true beam photoelectric sensor and electric linear actuator as input and output device. From the result, the prototype design, working principle, and cost to fabricate the machine are to be determined. Moving on to the next section, which is introduction and background. Production line for mineral water bottle consists of water treatment process, PET, bottle fabrication process, water filling process, labeling process, and lastly, the packaging process. The packaging process for mineral bottles is at the final stage of the production line. The bottles filled with mineral water will be sorted in package, which will be placed into the box by the packaging machine. As in the figure below, this is the example of the production line of the mineral bottle. This is the example of the packaging machine. The model of this packaging machine is Hamrick 300E drop packer. Let me introduce the company where the project will be carried out. Swatsander Berhad, or ESSB, is an SME company that involved in the production of mineral water bottle. The production plant of this company located at Simpang Renggam, Johor, where the water is obtained from a well of 200 meter deep down. The production of mineral water is licensed by Ministry of Health Malaysia and certified by Halal Al-Masti. Brands such as Faiza, Yakin, Darushifa, Tabung Haji, Infaq and Nature Choice are produced at ESSB plant. With the employee of 10, ESSB can produce approximately 24,000 of 125 to 600 ml, 12,000 mineral water bottle for 1.5 and 1.25 liters per month. This is the front of the ESSP plant. Now, I will continue my presentation on the literature review. My first literature review is automatic packaging machine. The packaging is the technology by which conveyor belts are used to encase or secure food, wood, and material for packaging, bundles, and merchandise into container for the distribution purpose. The usage of the automatic packaging machine fulfill the industry criteria, customer needs, retain food safety, and mitigate environmental impacts. This is the flow of the filling process, starting with the bottle on the conveyor line detected by the sensor, and after that, the bottle will continue to move to the automatic packaging machine, and after that, the bottle will be transferred into the erected box, which is calmed by the case erector. The benefit of automatic packaging machine are the industrial and consumers' demand will be satisfied, the safety of the product can be ensured, the environmental impact will be mitigated, and lastly, the productivity of a production plant can be improved in terms of performing standardized and flexible technology. My next literature review is the automation in production process. Automation can be defined as the process with the reduction of human interference in comparison with manual operation. There are three types of automation in production. First, programmable automation. Programmable automation is known as the manufacturing equipment where the various product frameworks are capable of modifying the sequence of operation. Second, fixed automation. Fixed automation can be defined as the sequence of processing operations that are fixed by the equipment configuration. And lastly, the flexible automation. Flexible automation is a model expansion of the programmable where a high investment for the engineered system is customized. Now, I will present the literature review of the machine control. Machine control is the reduction of complexity and expenses on a project. The example of the machine control is a touch panel display on PLC or known as programmable logic control, which is programmed in a ladder diagram of the logic control, allow the human-machine interface or HMI to the application of an automated control system. PLC is an electronic equipment which is acting as the control device respecting the behavior pattern of the ladder diagram, and it is widely being used in the industrial area. PLC's application in the automation system requires an element of auxiliary in terms of manufacturing and synchronization and sequential control of processes. PLC also is widely used in executing the logic of the system. Now, I will present to you the literature review on the output device. Output device reminds the status of the machine concerning the application which is uploaded in the PLC, and the task will be carried out automatically. Direct current voltage is used as the output which is operated by PLC. The example of the output device are: first, pneumatic actuators; second, solenoid valve; third, alarm indicator; and lastly, motor. In this figure below, this is the example of the output device. On the left side is Festo double-acting pneumatic cylinder, and on the right side is RS Pro 3 two-way pneumatic solenoid valve. The next literature review is on sensor. Sensor is an electronic device that can sense the data and detect any occurrence and alteration. One of the sensor is proximity sensor. Proximity sensor can deliver data on a movement object to such threshold, but only to the degree which is meant by the body, which is less than or greater than any distance from a distance where the sensor is placed. The source for the proximity sensor is infrared LED, and the working principle for the proximity sensor is when the reflective boundary is at a certain distance from the LED, the transistor is triggered by the light into the state of conducting, and threshold level is exceeded by the reflected light. For the next literature review is design. There are several considerations must be taken in the design process. There are cost of the product, quality of the product, and lastly, the duration that must be taken to fabricate the product. Problem identification must be carried out before the design process, where a solution can be determined. Now, the literature review on CATIA software. CATIA software is a CAD software which allows the user to design the part of the product. A 3D solid model can be created depending on constraints manually or automatically. The application of CATIA in the design process is: first, for the conceptual design; secondly, for the definition of the product; third, for the manufacturing purpose; and lastly, the product simulation. We're moving on to the next literature review on part creation in CATIA. Part design workbench will be started when the process of a new model is created. File of the part will be saved as a CAD part extension. There are three default lanes are used for the creature feature in the part design process. Workbench of Sketcher is used in every part creation in CATIA, where it is begin with 2D profile. A single sketch can be seen in form of geometry in Sketcher during this process. After the part design in CATIA, we're moving on to the last literature review of this proposal, which is the assembly design in CATIA. Assembly design in CATIA is a group of components in one document, and the file of the assembly design in CATIA will be saved as CAD product extension. There is a specification tree which contains components which are inserted and the feature of constraint. The position of component must be fixed. There are also compass and snap tool which can manipulate the position of the component. The copy and paste features can duplicate the component in the assembly design in CATIA. Positioning of component can be done in translation and rotation movement. Constraint feature minimize the degree of freedom of a component in the assembly workspace. Now, we're moving on to the next section of the proposal, which is the problem statement and objective. Problem statement for this project is: the improper and failure to make a good design of machine will affect the cost, worker safety, and quality of the mineral water bottle production. Before the final design is obtained, the correct specification of input device, controller, and the output device for the automatic bottling packaging machine must be known. The failure to select the proper mechanism of the machine will increase the time consuming to operate the whole production line of the bottle, the increasing of cost, and less productivity of the production line. The objective of this project are to identify how to make the automatic bottling packaging machine into the box, and second, to design and simulate the automatic bottling packaging machine. Now, we're moving on to the scope and limitation of the project. The scope of the project will be focused on researching on automatic bottling packaging machine. Second, the selection of the correct device and design for the automatic bottling packaging machine. Third, the working principle of automatic bottling packaging machine. And lastly, design and simulation of the prototype by using CAD software. The limitation of the project are: the restriction movement control order due to COVID-19 cases in the country make us difficult to travel to the plant. The site visit to the factory of the mineral bottle production plant cannot be conducted. The dimension of the prototype must be fitted according to the plan of the mineral bottle. Now, we're moving on to the methodology section in this proposal. As you can see here, this is the flowchart of the research. First, the activity and process which is being carried out is data collection and research on the automatic bottling packaging machine. And after that, the problem statement are determined and the working principle and device which will be used for the machine are identified. And after those process, the idea of the design must be drafted, and the idea of the drafted must be revised with the supervisor. If the drafted design is improper, it must be identified from the design what are the potential problems that can occur which can affect the cost, safety, reliability, and quality of the product. And after that, the design must be fit as to overcome the problem which might be occur. After the design is proper and evaluated by the supervisor, the CAD design using CATIA software is being made. Now we're moving on to the draft design of the idea. The design is drafted and sketched on paper. As you can see here, this is the top view and the front view of the packaging part in the machine. The part of the machine is listed. This is the isometric view of the cross-section for the packaging part of the machine. The idea is drafted on the paper. As you can see here, the part of the packaging is listed. At the left side is the actuator number 2, which is the electric linear actuator, and up of the actuator is the side wall of the top rack, which will be the wall that contain the bottle, and on the right side at the top is the lane guider, which will guide the bottle to stay on its lane, and below of the lane guider is the pusher. The pusher will be actuated by the actuator and be pushed to the forward and reverse. When the pusher is pushed to the forward, the bottle will be fall down into the erected box. Now we're moving on to the expected result in this proposal. As you can see here, this is the prototype of the automatic bottling packaging machine in CATIA software. As you can see here, this is the actuator 1, which is the electric linear actuator, sensor 1, the true beam photoelectric sensor, actuator 2, which is same as actuator 1, which is the electric linear actuator, the lane guider, which will guide the bottle when going into this section, and sensor 2, which is the photoelectric sensor, which is same as the sensor 1, and lastly the pusher, which will be actuated by the actuator 2 and make the bottle fall down into the box.
Now I will present to you the expected result from this project. As you can see here, this is the table of the working principle for the automatic bottling packaging machine. I will brief you the process of the working principle for this machine. At the beginning of the process, the bottle will move on the conveyor, and next, at the bottle feeding, a true beam photoelectric sensor number 1 will detect the moving bottles on the conveyor. As the 4 bottles are detected by the sensor number 1, and actuator number 1, which is the electric linear actuator, will retract, and the bottle will continue move to the next section of the conveyor. Then the second sensor, which is same as the sensor number 1, which is a true beam photoelectric sensor number 2, will detect the first bottle of the 4 bottles. A signal will be sent to the PLC, and the linear actuator number 1 will extend. The bottles will push through the lane guider of the packaging machine. The process continues in a loop until the top rack of the packaging machine are fitted with 24 bottles. As true beam photoelectric sensor number 2 sense the bottle, the linear actuator number 2 will be triggered and will be extended, which cause the pusher to move forward, and then the 24 bottle will fall into the box. And after a moment, the electric linear actuator number 2 will retract. Now, I will move on to the last expected result of this project, which is the cost to fabricate the automatic bottling packaging machine. The first part is the true beam photoelectric sensor, and it requires 3 to do this project. And the total cost for the true beam photoelectric sensor for 3 quantity is 484.50 cents. The second part is the electric linear actuator. The quantity needed for this actuator is 2, and the total cost is 363.20 cents. The third part is the aluminium plate, and the quantity needed is 5, and the total cost for the plate is 200 ringgit. And the fourth part is 100 horsepower, 450 volt, 3-phase electric motor, and in this project the motor is required for 1, and the total cost is 300 ringgit. For the fifth part is the steel plate, and the quantity needed is 2, and for the total cost is 60 ringgit. And the sixth part is the steel square hollow, and it requires 10 steel square hollow to do this project. The total cost is 1070 ringgit. And then the silencer, it requires 7 silencer in this project, and the total cost is 210 ringgit. And the eighth part is the directional control valve. It requires 4 valves in this project, and the total cost for the valve is 1200 ringgit. For the ninth part is the compressor. It requires only 1 compressor in this project, and the total cost for the compressor is 500 ringgit. For the grand total cost for fabricating the packaging machine is 4,387 ringgit and 50 cents.